Hello students, welcome to my channel Positron. The name of my channel is Positron. This channel is dedicated to the physics, especially for the students of 11th, 12th, those who are preparing for NEET, ITJ and other competitive examinations. I mean state examinations. Dear students, this is going to be my first video. I will try my best to bring you all in that track. Dear student, I promise you that my speed will be such that I will maintain the course and I will complete the course in due time. The name of my channel is very interesting. It is positron. Why it is positron? Actually, you know the fundamental particles about like electron, proton, neutron are similar. These fundamental particles have their antiparticles. Similarly, electron has the antiparticle that is called positron, and proton, neutron also have their antiparticles. So positron is actually the mass of positron is similar to mass of electron, but the charge is opposite to the charge of electron, means it is positive charge. So the name of my channel, again I'm repeating, is Positron. Dear students, I'm beginning from very basics, that is unit and measurement. I'm beginning my journey with you all from unit and measurement. The first topic is a system of units. Dear students, now the question is that why do we have need of system of units? Actually, the 19th century was a century of industrial revolution. Many of the new inventions were taking place, and that has paved the path for the new dimensions, new businesses, new industries that were taking place all across the globe. So, to develop the business, to carry on the business between different countries, it need to have a uniform system of unit, because in olden days, even in India, even in the different states, different cities of India, the local units were in use. So knowing that the business can grow only when we have a uniform system of unit. So Office of Weight and Measurement was established, I think it's 1888, 1890, in Séville, a place near Paris, the capital of France. Now, dear students, let's begin. System of unit. The system of unit used across the globe, the basically three system of unit. One is a MKS, that is stands for meter kilogram second. It is also expressed as SI, that is System D International. Actually, it is just a French test. Second one is a CGS, centimeter gram second. This is even today it is used in France and Britain, in most part of the Europe. Even today it is used. And third one is a FPS. FPS is a foot pound and second. This is used in Britain and France even today. Actually, there is a book, very famous book, that is called Resnick Holiday. People used to study that book. In that book, all the units are in FPS system. Most of the units are in FPS system. So the three basic unit system of units are MKS, that is said to be the SI System D International. The second one is a CGS, centimeter gram second, and third one is a FPS, foot pound and second. Now, dear students, let's move further. Types of physical quantities. Dear students, in physics, we come across with many kind of physical quantities. They are basically divided into three types. First one is a fundamental quantities. Fundamental quantities. Second one is a derived quantities. And third one is a complementary quantities. What I said, that the physical quantities are divided into three types. One is a fundamental, second one is a derived, and third one is a complementary quantities. Fundamental quantities are 7 quantities, you know. One is a length, the SI unit of is meter. Second one is a mass, SI unit is a kg. Third one is a time, SI unit is a second. Fourth one is a temperature, that is SI unit is a Kelvin. Fifth one is a electric current. SI unit is a ampere. Sixth one is a amount of substance. SI unit is a mole. And the last one, that is a luminous intensity, that is candela. Its SI unit is a candela. Dear students, I have written here the fundamental quantities. First one is a length, that is SI unit is a meter. Second one is a mass, having the SI unit kg. Third one is a time, that is SI unit is a second. Temperature Kelvin. Electric current, that is ampere. Current, amount of substance, that is mole. And luminous intensity, that's expressed in terms of candela. Now derived fundamental quantities are what? Those quantities which can be defined independently. They are said to be the fundamental quantity. Like these quantities, if you are defining the length, there is no need to describe the mass. Or if you defining the mass, there is no need to describe the length. So these are the fundamental quantities. They can be expressed independently. Now derived quantities. Derived quantities, they are infinite derived quantities. Those quantities which are expressed in terms of fundamental quantities, are the quantities which are expressed in terms of fundamental quantities are said to be the derived quantities, are the quantities which are derived from fundamental quantities are said to be the derived quantity. Like velocity that is meter per second, means displacement over time, speed, momentum, force, all that except of these 7. And they are the two quantities complementary are the two. One is a angle and another is a solid angle. These two are the complementary quantities. These 7 are the fundamental quantities. Except of these 9 quantities, all other quantities, except of these 9 quantities, all other quantities are derived quantities. Are you can say derived quantities are the quantities which are derived from fundamental quantities. These two quantities are angle and solid angle. The unit of angle is a radian and unit of solid angle is steradian. Dear students, it is a 2D, it is a 3D. Angle is made by a arc at the center, whereas solid angle is the angle created by area at a point is said to be the solid angle. For example, this is, let's consider a circle and it is the center of the circle, and this is the arc of the circle. Let it is subtending an angle theta. The radii is r, length of the arc is s, then angle theta is equal to arc upon radius. Dear students, theta is generally expressed in degree, but here we need to express for the mathematical calculations, you have to express in terms of radian. So the conversion formula is a very simple, that is pi radian equal to 180 degree. Pi radian is equal to 180 degree. This should be used. Second one is a solid angle. What I said, that angle is subtended at a point or at a center by the arc, and solid angle is the angle subtended at a point by an area. And solid angle is actually, it is represented by omega, and that is omega equals to a upon r square, area upon r square, and this is expressed in term of steradian. The unit of solid angle is a steradian. Similarly, the unit of angle is a radian, whereas angle of solid angle is expressed in terms of steradian. Now, dear students, it was just a basics. We are discussing the basics of the physics. Dear student, my name is Dr. Ranjan Kumar Mishra. I am MSc in Physics and PhD in Physics. What I have learned in my life, sometime, it's important to understand everything. You should try hard to understand anything, any concept in physics, but sometimes it is also important to remember the things, to learn the things. Like, I know everybody, even a common student, has mug up minimum 100 of the mobile numbers. You know your sis mobile number, your brother's mobile number, your dad mobile number, your mom mobile number, and many other kith and kins you know about. Similarly, some of the physical formula that should be on your tongue, and this will write a story of success for you, I'm sure. Now, dear students, let us discuss about the fundamental quantities and their definitions. First one is a length, and its SI unit is a meter. How will you define? The first one is a first fundamental quantity is a length, and SI unit is a meter. Very simply you can define it. Actually, 1 meter is the distance equal to 1650763.73 times of wavelength of orange color wave emanating from Krypton 86. The definition is length. 1 meter is the distance that is equal to the 1650760.73 times of wavelength of orange color wave that is emanating from Krypton 86. Krypton 86 is the isotope of krypton. Like hydrogen has 3 isotopes, 1H1, 1S2, 1S3. They are said to be the protium, deuterium, and tritium. Isotopes are what? Having the same atomic number but different mass numbers. Having the same atomic number but different mass number. These kind of nucleus is said to be the isotope. Similarly, krypton has an isotope that is krypton 86. Actually, it is a radioactive material continuously used to radiate, and the radiation is an orange color. And it is said that 1 meter is the distance equal to the 1650760.73 times of wavelength of orange color wave emanating from Krypton 86. What is the wavelength? Length of one wave is said to be the wavelength. Like a wave is expressed like this, right? The length of this wave is this from here to here. This is said to be the wavelength. 1 meter is the this times 1650763.73 times of wavelength of this wave that is coming out from Krypton 86. right? Krypton 86 is what? That is isotope of krypton. Now, dear students, let's move further. It is the standard 1 meter I have defined. If you just forget this very definition, then even a very simple definition that a rod made of platinum iridium kept in Xavier, Paris, when there is, I already have said you that in the Xavier, near Paris, capital of France, there they are situated the International Office of Weight and Measurement. Now, dear student, a rod, a prototype rod kept in Xavier, Paris, that is made of platinum iridium, and there are the two marks on that rod. At 0 degrees C, the distance between the two marks is also 1 meter. A prototype or a rod made of platinum plus iridium, right? Platinum plus iridium, right? There are the two marks at 0 degrees C. The distance between these two marks is said to be the 1 meter. Why do we consider platinum iridium? Actually, platinum and iridium are the two different metals. Platinum is a rare, very rare metal and very costly, even 10 times costlier than the gold. You know, it is said to be the white gold. So, dear students, why do we consider the mixture of platinum and iridium? Simply because if you consider the mixture of platinum and iridium, then in the winters, you know, the temperature changes as the season changes. So, the change of temperature may bring the change in the length of the rod. If you consider the mixture of platinum and iridium, then this change will be minimum because the coefficient of linear expansion, that is alpha, is a very, very less for the platinum and iridium. So, I mean to say that why do we consider the mixture of platinum and iridium? Simply because there will be the change in the length will be minimum due to change in temperature. Now, dear students, this was the length we have talked about. That is standard length or standard meter I have defined. The two definitions I have given you. Now, let's talk about the smallest unit. You know, what is the smallest unit? You know, 1 meter is equal to 10 to the power 2 centimeter, or 1 centimeter is equal to 10 power minus 2 meter. 1 millimeter is equal to 10 to the power minus 3 meter. It's interesting to talk about. If you are a student of physics, for me, you should know basics of the physics. And you should create the interest. You should be interested to know everything about. 1 millimeter is 10 to the power minus 3 meter. 1 micron is what? 1 micron, that is 10 to the power minus 6 meter. Then comes after the micron, that is a 1 nanometer, that is equal to 10 to the power minus 9 meter. Then comes angstrom, that is 10 to the power minus 10 meter. You know the angstrom is a very useful unit, a small unit of length that is used to measure the wavelength of waves or light. You know the wavelength of visible light exists between 4000 to 8000 angstrom, right? The red color light has the maximum wavelength that is approximately equal to 8000 angstrom, whereas the violet color has the minimum wavelength that is approximately 4000 angstrom. Now comes further, let's move, that is we say 1 picometer, that is equal to 10 power minus 12 meter, and then comes 1 Fermi, that is equal to 10 power minus 15 meter. Fermi is a very useful meter for getting the atomic dimensions, are basically the diameter of an atom is expressed in terms of Fermi. Fermi was a French-born great mathematician, all-time great mathematician, and this unit is dedicated to this great man. Now, it was the shorter unit, the smaller units of the length we are talking about. Now, we have to talk about the bigger units of the length. What are the bigger units? One is a very important unit, that is AU. AU is said to be the astronomical unit, right? That is equal to 1.496 into 10 raised to the power 11 meter. Actually, AU itself is a unit, right? Sometimes AU itself is a unit, and one astronomical unit, that is equal to 1.496 into 10 raised to the power 11 meter. What is this? AU is what? You know, this is the sun, and all the planets are revolving around the sun in different elliptical orbits, whereas sun is located at their one foci. Dear students, all the planets are revolving around the sun, whereas sun is located at their one foci. So earth is revolving around the sun, right? It is not only revolving but spinning also. So earth is revolving and spinning both around the sun. Now the average distance between the sun and earth, this distance, this is said to be the 1 AU. The average distance between the earth and sun, that is said to be the 1 AU, and that works out to be 1.496 into 10 raised to the power 11 meter. Now let's talk for the bigger unit, that is a 1 light year. 1 light year, that is distance traveled by light in 1 year said to be the 1 light year, and that works out to be 9.46 into 10 raised to the power 15 meter. 9.46 into 10 raised to the power 15 meter. And the biggest unit, that is a parsec. 1 parsec, that is said to be the parallactic second. I think I'm not sure, but it is something 3.08 into 10 raised to the power 16 meter, like this. I'm not very sure, but this is 3.08 into 10 power 16 meter, or you can say 3 into 10 power 16 meter. This is the biggest unit of the distance. In many time it has been the part of NEET examination that parsec is the unit of. Then actually it appears that, it sounds that it is a unit of time, but it is not so. Parallactic second, it is a unit of length. 1 parallactic second is what? It is the distance at which an arc equal to 1 AU makes a 1 arc second angle. If an arc that has a length of 1 astronomical unit, means 1.496 into 10 power 11 meter. This arc has a length 1.496 into 10 power 11 meter. Then the distance at which this arc is making an angle 1 arc second is said to be, that is a parallactic second. This distance is a 1 parsec. This way distance is a 1 parsec. The distance, if an arc has a length of 1 astronomical unit, then the distance at which this arc is subtending an angle 1 arc second is said to be the 1 parsec. And dear student, 1 arc second is what? That is a 1 arc second, that is 1 upon 3600 degree. Always remember these small steps. 1 arc second, that is equal to 1 upon 3600 degree. Dear students, the parallactic second is the greatest unit of length, and that is used to measure the distance between the stars. If you have to find out the distance between the stars, then the appropriate, the most relevant unit is undoubtedly parsec, parallactic second. Now, let's move further. Second one is a mass. The SI unit of mass is 1 kg. Dear students, there are many definitions. If you just forget every definition, then you simply can say that a prototype cylinder made of platinum iridium kept in Paris has a mass 1 kg, right? A prototype cylinder made of platinum and iridium has a mass 1 kg. Actually, the mass, whenever you go for the shopping for the groceries, then for the weighing purposes, the mass actually allotted from the Paris, and then it comes to the NPL New Delhi in India, which agency is responsible for the measurement in the country, that is NPL, National Fiscal Laboratory, New Delhi. Actually, the prototype weight is distributed from the NPL Delhi throughout the country, right? So 1 kg, how you define? 1 kg is equal to, that is a 1 kg, it is a mass of a prototype cylinder kept in Xavier, Paris, that is made of platinum iridium. There are also many definitions, like the mass of 1 liter pure water at 4 degrees C. The mass of 1 liter pure water at 4 degrees C is also 1 kg. Pure water means rainy water. Why do we consider at 4 degrees C? Because water has maximum density at 4 degrees C. Below 4 degrees C, it begin to convert into ice. So, the mass of 1 kg water at 4 degrees C is also, that is equal to the 1 kg. Now, for the smaller units, if the mass of our sun, that is found in terms of kg. But dear students, if you have to find out the atomic masses, then a different unit is used, that is said to be 1 AMU. AMU is an atomic mass unit. And that works out to be 1.67 into 10 raised to the power minus 27 kg. And what is that? This is 1 by 12 of mass of 1 carbon 12 atom. This work out to be 1 AMU, atomic mass unit, that works out to be 1.67 to 10 power minus 27 kg, and that is what? 1 by 12 into mass of 1 carbon 12 atom divided by 12, that results into 1 AMU, and that works out to be 1.67 into 10 power minus 27 kg. I think the mass of Earth is nearly 10 power 25 or 27 kg. Here you have to remember just the order for the mathematical calculation for comparison. Basically, if mass is higher, you know the gravity would be higher, right? And mass of the sun is nearly, the order of mass of sun is 10 to the power 31 kg. You know it's easy. If a lander goes to the moon, then it can return back to the earth, right? It can come back to the orbit. But if a person lands on the Mars, then he cannot return back to the earth. Why? It is because of gravity. There is no technology that a person, if lands on the Mars, and it will come back. There is a great lady, she is going to sacrifice her life, Alice Carlson from US, NASA. I think in 2033, she will go to the Mars and will never come back. I think it is the biggest sacrifice for a human being for the coming generations. Now let's move further, dear students. Third one is first one we talked about the length, second one we talked about the mass, and third one is time. Time is the SI unit of time is a second. Now how do you define the 1 second? Actually, the wristwatch you are using or the time you are using, simply there is a problem, we do not need much accuracy of precision. But if you are going on the space, right, for the spaceship, for the launch of rocket, there should be accuracy, there should be precision in the measurement of time. And that accuracy is up to the 1 part of 10 million, right? The accuracy in measurement of time is 1 part in 10 million. So we use atomic watches. For that purpose, it is atomic watches are used. So how will you define 1 second? 1 second is the time. 1 second is the time duration is the time duration in which hyperfine structure of cesium 136, I think 133, I'm missing bit. Cesium 136 makes 192, 631, 770 radiations. Now, dear students, very important that what is the hyperfine structure? You know that electrons are revolving in different closed and circular orbits around the nucleus. In different orbits, this is a structure, diatomic structure. If this orbit is further divided into suborbits, SPDF, this is a hyperfine structure, right? So, between the two hyperfine structure of cesium 136, this number of radiation takes in 1 second. Between the two hyperfine levels of cesium 136, 192, 631, 770 vibrations or radiations takes in 1 second. In 1 second, this much number of radiation will take place in cesium 136 hyperfine structure, right? Means in cesium 136 or 133, I'm missing a bit, it is isotope of cesium, right? So, perhaps it is 133. That the hyperfine structure of cesium 133 that makes 192, 631, 770 radiations in 1 second. Now, dear students, let's move further. The fourth one is a temperature that we represent in Kelvin. Now we have to define, how will you define Kelvin? Actually, here is a concept of triple temperature. Triple temperature is what? The temperature at which water exists in all the three states together. The three states are what? Solid, liquid and gas, right? And that works out to be the triple temperature of water is that works out to be 273.16. So if you divide this quantity by the same 273.16 divided by 273.16, that result into 1 Kelvin. So 1 Kelvin is 1 upon 273.16 times of triple temperature of water. Dear students, as I have said that triple temperature is what? Triple temperature of water is the temperature at which water exists in all the three states, solid, liquid and gas together. That is said to be the triple temperature. Now, triple temperature of water is actually 273.16. So, 1 Kelvin is what? 1 upon 273.16 times of triple temperature of water. Triple temperature of water is this. If this quantity is multiplied by this quantity, that will result into 1 Kelvin. So, 1 Kelvin is a 1 upon 273.16 times of triple temperature of water. Now, dear students, this is not only the one unit that is used in measurement of temperature. Many units are used. That is one is a Kelvin, and the is a degree centigrade, and the is a Fahrenheit that doctors used to use for the medical purposes, right? How the Kelvin can be converted into degree C, right? T Kelvin is equal to, if a temperature is given into Celsius, that is, add this by 273.16, you will get the Kelvin, right? If it is, generally we used to add 273 only. If it is given in Celsius, just add 273, you will get in Kelvin. Now, how the Celsius can be converted. How this conversion is possible? First convert the Celsius into Fahrenheit, and then Fahrenheit into Celsius, and then Celsius can be converted into Kelvin just by adding 273. So what is the formula used for the conversion of Fahrenheit into Celsius or Celsius into Fahrenheit? That is a F minus 32 upon 9, that is equal to C by 5. Simply, the conversion formula is F minus 32 upon 9, that is equal to C by 5. You also can prove this formula. It's a very simple. Let the unknown temperature on the Celsius is a C, right? And that is a, the boiling point of water is 100. Similarly here, actually the unknown temperature is a, just I'm missing, but the difference between the boiling point, here it is a boiling point and freezing point is 0, so 100 minus 0, and here the boiling point on the Fahrenheit scale is I think 232, and the difference between the boiling point and freezing point of water on Fahrenheit scale, that works out to be 180 actually, right? And this is F minus 32. If you will solve this, 25 and that is 20. Why it is written as 32? Actually, now I remember it. Here the formula is C minus 0. 0 is a freezing point. It is a difference of unknown temperature and freezing point, and it is a difference of boiling point and freezing point. And here you will write F minus the freezing point on the Fahrenheit scale is a 32, and between the freezing point and boiling point there is a 180 divisions, so it is 180. So 25 or 29, so you will get the formula, that is F minus 32 by 9, that is equal to C by 5. Actually, the freezing point on the Fahrenheit scale, 32 degree Fahrenheit for the water, the freezing point of water on Fahrenheit scale is a 32 degree Fahrenheit, whereas the boiling point is a 212 degree Fahrenheit. If you subtract these two, you will get 180, right? Between the freezing point and boiling point, there is a difference of 180 degree Fahrenheit. And similarly, on the Celsius scale, the difference between the boiling point and freezing point is 100 degrees C. So here it is 100, here it is 180. Just 25 or 29 you will get. Dear students, the formula is F minus 32 upon 9, that is equal to C by 5. By using this formula, you can convert the Fahrenheit into Celsius or Celsius into Fahrenheit. You know, the normal temperature of human body is what is that is 98.6 degree Fahrenheit. If you put this value here, you will get 98.6 degree Fahrenheit minus 32 upon 9, that is equal to C by 5. Now solve this. What the result you get would be interesting to know. C is equal to 5, I am bringing here 5 by 9 into, now just it will be 0.6, that is a 8 minus 2 is a 6, and 9 minus 3 is a 6. So C is equal to 5 into 9 7 are 66 and 9 4 are 36. Multiply by 5, this is 5 4 are 22, 5 7 are 37 degrees C. Means you can say the normal temperature of human body is either 98.6 degree Fahrenheit, or in Celsius you can say is a 37 degrees C. How I have how I have established this conversion formula? Very simply, F minus 32 upon 9 is equal to C upon 5. C is an unknown temperature on Celsius scale. This is C minus freezing point is 0 upon boiling point minus freezing point, that is 100 minus 0, that is equal to 100. And here it is a freezing point minus boiling point, that is 212 minus 32, that is equal to 180 divisions, and unknown temperature on Fahrenheit scale F minus freezing point is a 32. If you will solve, you will get this. Now dear students, I am sure it is not going to be the part of your examination, but I am trying to let you understand the basics of the physics that will make you strong and that will make you familiar with the physics. That's why I am trying very hard. Now dear students, this was we discussed length, we discussed mass, we discussed time, we discussed that is temperature. The fifth one is that is electric current. Electric current is what? That is ampere. Right? The SI unit is ampere. How will you define 1 ampere? You know, I is what? Rate of flow of charge is called current. 1 coulomb divided by 1 second. Means, if from a point 1 coulomb charges in 1 second, then it is said to be the 1 ampere. Right? How will you define the 1 ampere? If 1 coulomb charges passes in 1 second from a point, then current flowing would be the 1 ampere. But this is not a standard definition. The standard definition is what? If the two long, straight and parallel wires kept at 1 meter away, if the two long, straight and parallel wires kept at 1 meter away and at per unit length they are experiencing a force of 2 into 10 to the power minus 7 Newton, then the current flowing in the wires will be 1 ampere. Dear students, let this is I1, I2, I1 equal to I2 equal to 1 ampere. How will you define? If the two long, straight and parallel wires, if the two infinite, long, straight and parallel wires kept at 1 meter away and at per unit length they experience a force of 2 into 10 to the power minus 7 Newton, then the current flowing in the wires will be 1 ampere. Now dear students, next one is that is a amount of substance. Sixth one is the amount of substance. That is mole. How will you define 1 mole? 1 mole is the amount of substance in which number of entities will be equal to the number of carbon-12 atom in 0.012 kilogram carbon-12 atom. Means 1 mole is a number of entities, number of elementary quantities, that is equal to number of carbon-12 atom in 0.012 kg. Means first you have to consider in carbon-12 in 0.012 kg carbon-12 atom, how many carbon atoms will be there, right? And that will be equal to the 1 mole. So 1 mole, again I am repeating my words, 1 mole is equal to the number of elementary quantities, that is number of carbon-12 atoms in 0.012 kg. It means 1 mole is a elementary quantity, number of elements, that is equal to the number of carbon-12 atoms in 0.012 kg, right? Again I am repeating, 1 mole what? It is number of, very simply it is number of elements, that is equal to the number of carbon-12 atom in 0.012 kg of sample, of carbon-12 sample. Last one is a luminous intensity. That is a luminous intensity that is expressed in terms of candela. Dear students, candela is about, this is a measurement. This is a unit for measuring the brightness of a source. One candela, how you define? If a source is emitting the radiation 540 into 10 raised to the power 12 Hertz. Hertz was a very famous scientist, and this unit of frequency is dedicated to that name. Hertz, Marconi, J.C. Bose, all they were related to the radio waves. Hertz, J.C. Bose, Marconi, they are the first to study or to receive and detect the electromagnetic wave. So, dear student, one candela, how you define? That is a radiation, a source which is emitting the radiation of 540 into 10 to the power 12 Hertz, and in that direction, the radiant intensity is 1 upon 683 watt per steradian. Then luminous intensity of the source would be 1 candela. Again I am repeating, if a source is emitting the radiation of that much, means if a source is emitting the radiation of 540 into 10 raised to the power 12 Hertz, and in that direction the radiant intensity is 1 upon 683 watt per steradian, then the luminous intensity of the source would be 1 candela. So dear students, today's topic was just we are discussing about the system of unit, and then its fundamental quantities, their definitions, right? Fundamental quantities, fundamental units, and their definitions. So least but not last, it's my request to you, if you think that my videos are going to be beneficial to you, then please and please share, comment, like, and subscribe, and put the bell icon so that you can be notified about my next videos. Till then, goodbye, bye-bye. Meet you in next video. Bye. So.